Okay, today we are talking about linear functions, lines. You guys have over the time in Algebra 1 and then in Algebra 2 written equations of lines, y equals mx plus b, other forms, which we will again review today. So here's your objectives. We'll be able to calculate a line slope, write our equation in point slope form, and also we will be able to graph and write our equations in slope-intercept form. And then I'm going to remind you of the other form and how our book calls that as well. First of all, slope of a line. If we are just looking at a linear equation, the slope describes the steepness of that line. Okay. Now, there are several different ways that it is referred to, and so I've kind of put all of those so you can think about that. We always go up or down first, right or left second when describing the steepness of a line. So if I were to compare any 2 points on the line, and it doesn't matter which 2 points we are looking at, the steepness can be described as the rise over run are the two words that are commonly used to describe slope, which would be the difference in the y value from this point up to this point. So y2 minus y1. Subtracting finds the difference between two values. So finding out how far up we go would be y2 minus y1. And then how far over we go, the run part of it, would be the difference in our x values, x2 minus x1. It can be called the change in your y values over the change in your x values. Rise over run. There's your actual formula, y2 minus y1 over x2 minus x1. I will show you that there is one more notation for this whole change in y over change in x. A mathematical symbol for showing change is the delta symbol. So delta y over delta x is another way of saying change in y over change in x using mathematical symbols. A common notation for slope is to use the letter m. Have you guys seen that before for slope? If I were to write out that equation, it would be m equals y2 minus y1 over x2 minus x1. I did find it interesting. I've never known what that stood for. This book told me. There you go. It's commonly represented by the letter m because of the French verb monter. Do I have any French people? I have no idea how to pronounce things in French. Monter? No? Maybe? Which apparently means to rise. So there you go. Now we know why it is denoted by the letter m. Another thing is always this. How am I supposed to know which one is the x2 and which one is the x1 and which one is the first? Guys, that is literally just labeling your points. They are saying this is point, well, let's start here. This is point 1, and this is point 2. And so they put a little subscript so that you can kind of distinguish which point the x and the y value came from. But if I were to flip-flop and call this one point 1 and this one point 2, would it change my slope? Not at all. You pick. Just let one of them be the first point and let one of them be the second point. Be consistent, though, so whichever y value you call point 1 is your x value for point 1. Okay? Consistency. All right, so very basic. Find the slope of the line that passes through each pair of points. Every ordered pair goes x comma y, right? So every ordered pair goes x comma y, x comma y. We pick one of them to be our first point and one of them to be our second point. If they were listed this way, I'd probably call the first one point 1 and the second one point 2. So you can see where those little x1s and y1s come from. Every ordered pair is x, y. Pick one of them to be your first point, okay? So then when we do our formula that says do y2 minus y1, I go take my y values. 2 minus 4, y2 minus y1. And then it says do x2 minus x1. Make sure you're consistent. If I started with this y value, I have to start with this x value. Negative 4 minus negative becomes a plus, right? Minus negative 3, that guy right there, was minus negative plus 3. I just want you to make sure that I'm not like adding a positive plus into the formula, right? Cleaning that up, 2 minus 4 is negative 2. Negative 4 plus 3 is negative 1. Always simplify every fraction. A negative over a negative is a positive. Technically, it would be fine to make it 2 over 1. I would simplify down to just positive 2, though. Now, very, very, very quickly, what if I were to switch these two and make this my first point and this my second point? I just want to prove to you that it would not change my answer. So then I would do y2 minus y1, which would be 4 minus 2, and x2 minus x1, negative 3 minus negative 4. 4 minus 2 is 2. Negative 3 plus 4 is 1. Simplifies down to 2. So please do not stress over which one is the first point and the second point. It doesn't matter. You get the same slope. Just be careful with your positives and negatives and the order that you start things in, okay? All right, moving on. What do we have for possibilities? Well, if I came out with a positive number, my slope is going to rise as I go to the right. That's what the visual would look like. If I came out with a negative number, meaning either the top or the bottom were negative but not both, right? That's how we would simplify down to a negative number. My graph would fall as I go to the right. The other possibilities is it doesn't rise or fall as you go to the right. And that would be a horizontal line has a slope of 0. And a vertical line has a slope of undefined. And those two are always forgotten or confused for each other. This is my little silly way that I used to teach it in Algebra 1. You think of like a slope like on a mountain if you were to go skiing, right? Mountains have slopes that you ski on, okay? Well, if my little skier guy was on this horizontal line and he fell over, I don't know if you've been skiing, but if you fall over on a flat surface, it doesn't hurt. You just fall into some nice soft snow. It is 0 pain if you fall over on a horizontal line. Now, if that same little skier guy was standing here at the top of a cliff and he fell over, he's in undefined amounts of pain, right? Because he just fell off a cliff. Okay, so maybe that'll help you remember the difference between undefined, if you fall off a vertical line, undefined pain, versus if you fall over on a horizontal line, no pain, 0 pain, right? So the difference between those two. This would look like m equals 0. This would look like m equals undefined. We will revisit those two types of lines here in a few minutes. Today we're going to talk about 3 different forms of the equation of a line. They are all equivalent. Why would I use the different types? I would use the different types based on what is handed to me at the beginning of the problem. Typically, we start writing our equation using point-slope form because that is usually the type of information that is handed to us at the beginning of a problem. And this is your point-slope form. Y minus y1 equals m times x minus x1. Notice I have a couple things highlighted in there. x1 and y1 would be any point on the line. So this whole x1 comma y1 that you see in that equation is any point on the line. And I can put in any point on the line. It would still end up being the same. And then m is our slope. The y and the x that you see written up there in the black will always be there. They are literally the letters y and x, and they will not change. The numbers in blue and in green will be actual numbers that we will fill in specific to our line. Okay? So writing an equation in point-slope form, we could be handed 2 different types of information. We could just be told the slope and a point on our line. And if that is what is handed to us initially, then we just put those in the correct place, remembering that every ordered pair goes x comma y. And this now becomes the point on my line that I'm using here as x1, y1 in our equation above. So every point-slope form starts with y minus. And then I go get the y value from a point on my line, which would be in this case 3. So I'd fill that in here. Equals our slope, which they told us is 4, x minus, and then I go get the x value of that same point that I used over here. And in this case, that would be negative 1. So x minus negative 1, right? And again, that was minus negative 1, just so you know that it's not plus in that formula. Okay. You could also be given, instead of the slope, you could just be given any 2 points on the line. And this means we have 1 step of work to do ahead of just plugging things into the correct place in our equation. Is first you must find the slope. So if you are handed 2 points at the beginning, to write the equation line, the first step you will always do is just find the slope of the line that goes through those 2 points. So again, remember that this is x1, y1, x2, y2. Again, just labeling it as my first and second point. I put those into my slope formula, y2 minus y1, 6 minus negative 3, over negative 2 minus 4. Be careful with your positives and negatives on this. If I have one negative in there, the number is negative, right? 6 and 9 are both divisible by 3, so this would be a negative 3 over 2 as I simplify that fraction. Now, I can use either of my points, so both of these equations would be correct. If I were to use this point right here, it would look like y minus our y equation, y minus our y value, y minus negative 3 equals our slope times x minus our x value of 4. I can also use the other point. They actually are the exact same equation. Now in point slope form, they would look different. But if I were to either graph it or move to my other form that we're going to see on the next page, slope intercept, we would get the exact same equation. So a second correct option would have been using that other point. Y minus 6 equals negative 3 halves times x minus negative 2. Those are both correct answers for this equation. Yeah. The negative 3 over 2 came from my slope formula. So I put the 2 points into there. Now 6 plus 3 gave me 9, and negative 2 minus 4 gave me negative 6. So that's where it started, but then both of those are divisible by 3. So if I divide that by 3, I get 3. I divide that by 3, I get 2, which is where the 3 halves came from. One of them was negative, which means the fraction is negative. If I had done them in the other order, the 9 would have been negative, the 6 would have been positive. And still a negative fraction. Any other questions on point slope form? Okay, second form of an equation is your slope intercept form. This is the one we are probably most comfortable with as far as graphing goes, and that is y equals mx plus b. It's also the one that we look at the most often and say, ooh, that's the equation of a line. In this, again, the y and the x that you see up there in black will always be a y and an x. Those are literally the letters that go there. We put our slope here where it says m. Now this one is a little bit different. The b at the end is your y-intercept, where it hits your y-axis. So on our y-axis, up here at some value b, our line would cross through if that was the number at the end of this equation, y equals mx plus b. Okay? Remember that those points on a y-intercept are always of the ordered pair 0, comma b. If they were to ask me what my y-intercept was looking at this equation, I could easily identify that as 0, comma b. Okay, so again, a couple different ways of writing an equation that goes through. We could be told the slope. We could be told just 2 points, because job number 1 is to start at point slope form when you are going to slope intercept. Okay, we'll always start here and move. So step number 1 is find your slope. If they tell that to you directly, you really don't have to do anything for step number 1, but we need to find our slope for step number 1. So step number 1, y2 minus y1 over x2 minus x1. Hopefully we're remembering that, right? So negative 6 minus 1 over negative 1 minus negative 2 would be a negative 7. Always check my work here. Over 1, or a slope of negative 7. All okay with that? Step 2, set up your point slope form. And that comes from the page we just left. Point slope form is where we start all of this, and then we will move to our y-intercept form. So setting up our point slope form, I pick either point. It does not matter. And again, I will super fast show you if we pick the other point that we would get the exact same answer. Let's go ahead and go with the negative 2, 1, okay? If I pick negative 2, 1 and put that into my point slope form, it would look like y minus my y value, which is 1, my slope, x minus my x value, which is negative 2, so minus a negative 2. Okay, step 3, distribute. Negative 7x minus 14. And step 4, it'll always be these last 2 steps. Distribute and then solve for y. Add or subtract to get y alone. Solve for y. So in this case, that would be to add 1 to both sides. And we get y equals negative 7x minus 13. I just want to show you again, please do not stress over picking the correct point. If I were to have done this with the other point, it would have looked like y minus negative 6, which would be plus 6. Negative 7 is still our slope. X minus negative 1. Distribute that through. Negative 7x minus 7. Subtract 6, and we get y equals negative 7x minus 13. Which is the exact same equation we had over here. You would always get the same equation. So please do not stress over which point to graph. And then drawing our equation, graph that line I have. Start here. So the graphing part of it. When we graph, you're going to start here. Put a dot on your y-axis. At this value, negative 13. So I would have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. I would have a dot down here on my y-axis at negative 13. Step 2 in graphing, do your slope. I need to make my slope, so maybe I can put my steps here. Dot at B on y-axis. That's what I did first. 2, make slope a fraction, and then do rise over run for another dot. So our fraction, if we go back up here, looked like this, didn't it? Negative 7 over 1, which means go down 7, right 1. So from here, ooh, I didn't give myself any room, did I? I'm going to switch that. Negative 7 over 1 is the same thing as 7 over negative 1, which would go up 7, left 1. Let's do that. 2, 3, 4, 5, 6, 7, left 1. As long as you have one negative, you can slide it up or down. It doesn't matter. But when we do our slope, remember that the top number is up and down, the bottom number is left and right, the same way we would think any positive or negative would move in our graph. Questions on that? Yes? Why did I do that? Because I would have had to count down 7, and I didn't give myself room to do that. So then I just switched the negative to the other part of the fraction. Literally because I ran out of room. Otherwise, I wouldn't have. Just because that would have been another step of work, which I wouldn't have to do normally. Other questions? Okay. Vertical and horizontal lines. These ones are so often confused for each other, so just giving ourselves a place to kind of map these out. When I am looking at a horizontal line, first of all, every point along this line goes over some distance up a same number. Whatever it is that whatever this value is up here, let's say this is up at some A, every point along here move to the right some distance up A, or left some distance up A. Notice all of the y values are the same on a horizontal line, which means when I look at the slope, my y values are all the same. When I do the change in y, there is no change in y. And so what you see on a horizontal line, if I were to do my slope equation is that I would end up with 0 in the top over some number in the bottom. And that simplifies down to a slope of 0. And the equation of the horizontal line is y equals some number, and that is whatever number is in the y value of the points that it goes through. Similar discussion for vertical lines, but vertical lines, as I move over the same distance before moving up and down, which means every point on this line moved over the same distance, comma something, or moved over the same distance to the right, comma something else to move us up and down on that line. We'd have to go over, say, B, whatever that is. And that would be our y value. So as I'm doing my slope equation, I would get some number, but B minus B would give me a 0 in the bottom of that fraction. And a 0 in the bottom of the fraction we cannot have, which is why you see that this is called undefined. So 0 over a number simplifies down to undefined. Also can be known as no slope. Kind of depends on what standardized test, what textbook, whatever. All means the same thing. Means that there is no value there. Okay, no value for that slope. The equation, because all of the points that are on that line have the same x value, our equation is of the format x equals some number. And that number will match the x value of any point on that line. So if they say it's a vertical line that goes through the point 1, 7, well then it's the equation x equals 1, because it will match the x value of any point on that line. If they say we've got a horizontal line that goes through 1, 7, it would be y equals 7, because it's going to match the y value of any ordered pair that it goes through. Questions? All right, our last form. In this book and in different places, it's called general form. You may have been introduced to it in Algebra 1 and Algebra 2 as standard form. Now, what I did find interesting is they write it a little bit differently. ax plus by plus c equals 0. And in a lot of our algebra textbooks in the past, it would have looked like ax plus by equals c. C being some constant. And the difference is having it equal to 0 or having it equal to the constant. Notice your x and y are still on the same side in both of those equations. I think it's easier actually to think of it with the constant on the other side, but that's kind of up to you. So how can we graph this? Guys, you have two options. If I'm looking at the general form of 3x minus 2y minus 6 equals 0, to graph it, we could graph from slope-intercept form. Which is not actually the way I'm going to do it on our graph over here, which means solve for y. If I choose to graph from slope-intercept form like I showed you here, you would solve for y, and this is what that would look like. If I want y by itself, I would move this to the other side, and I would move this to the other side first. So I would add 6. I would subtract 3x. I would divide everything by -2. A negative over negative is positive. And now I would start at my y-intercept and use my slope to graph that. That's option 1. Okay? Option 2 is to graph from your intercepts. If I'm talking about graphing from my x and y intercepts, remember that this is my x-axis, and that if it's going to be an x-intercept, that to hit our x-axis, that means it would have to be some number, comma, 0 to be an x-intercept. And so to graph from my x-intercept, to find it, I would plug in y equals 0. I would put a 0 in for y. Okay? So I would come up to this equation and put a 0 in here for y and solve for x. That's going to go to 0, and those of you that are quick and good with numbers, you would kind of be able to just eliminate that term right away. So this would go to 0 right here, add 6, divide by 3, and we would have a dot on our x-axis at 2. That's your x-intercept. Solving then for our y-intercept, again, to hit my y-axis, remember this is your y-axis, it would have to be 0, comma something. So we would plug 0 in for x. Solve for our y. This would be 0, add 6, divide by -2, and we get -3. So I would put a dot on my y-axis at -3 and connect the two dots. Any questions on that? Now, there's not necessarily a right or wrong way to graph that. Sometimes you'll be asked specifically to do one or the other. So just remember that there is multiple options when graphing from general form. Hopefully today was a lot of review stuff you remember. It's been a while, I know, but hopefully bringing that back into our brains here. Okay. We will have a unit objective quiz over all of this on Wednesday. You guys do have a little bit here where it talks about writing the slope-intercept form of the best fit line. If you guys remember what best fit line means, you had a scatter plot, and they would draw in a best fit line. Guys, when they do this, it is no different than finding the slope of the line that we had. However, find any points that it actually goes through. So for example, it specifically goes through that point and that point. Those would become then my point 1 and point 2 in my slope formula. So it doesn't change the fact that it's a scatter plot or a best fit line. We still do our slope formula. It's probably uglier numbers. Okay, that's fine. These are really ugly numbers because they've got decimals and everything. But it does not change our process. So if I were to set up finding my slope here, I know those numbers are really small up there, but it would be like 57.99 minus 57.06 over 385 minus 326. And you would get an ugly decimal in your calculator, and you would use your calculator for that. We are not trying to do that in our heads, okay? Questions? All right. We are not doing our check for understanding today because we have a unit objective quiz to do. You may use your notes, you may use your calculator. When you are done, you can get on your Chromebook and move to your assignment, which is on My Math Lab.